Anytime that we add terms in algebra, we need them to be the same. We need them to be like terms. If we're going to add something with variables like x, we need them to be exactly the same with the same exponent. The same thing goes for subtraction. If I was taking 5x squared and I wanted to subtract x squared, the variables and their exponents need to be the same. We call those like terms. Looking at these rational expressions, the denominators are not the same, so I don't have a way to combine them. So what I'm going to do is I'm going to modify each of the fractions so that I can add them. My goal is to make the two denominators the same. I'm going to think about what the least common denominator is between the two existing fractions. One of them has an x in the denominator and one of them has a y in the denominator, so the least common denominator for these two is going to be x times y. So for the fraction on the left, I want to multiply by y over y. This is just a form of 1. This is equal to 1. So I'm not changing the fraction that I'm multiplying by, I'm just changing the way that it looks. And then on the right-hand side, I'll multiply by x over x. That's also a form of 1, so I'm not changing the fraction, I'm just modifying it so that now both of my denominators are going to match. This is going to now become 4y plus 10x. And both of their denominators are x times y. And since they match, I can combine the numerators and have a single fraction with the same denominator. Let's look at example B. Example B has binomials in the denominators. So it doesn't look like they have anything in common, and I think that my least common denominator here is going to be z plus 1 times z minus 2. I'm going to write these over here so I can change both of these fractions to have the same denominator. I want my new denominators to look like this, so the first fraction needs a z minus 2 to make that happen. And my second fraction needs a z plus 1 to make that happen. All right, now I'm going to multiply the numerators out. I'm going to take this 3z and distribute it to both of these items. So we're going to have 3z squared minus 6z. And my new denominator is z plus 1 times z minus 2. And then going to my second fraction, I've got to multiply this whole thing by this whole thing. So let's see, that's going to be 2z squared. For the inner and the outer terms, we're going to have a 5z and a 2z. So that's going to be plus 7 7z. And then for our last terms, we'll have plus 5. And then in the denominator, we have z plus 1 and z minus 2. All right, now my denominators match, so I can combine all of the terms in the numerator. I'm going to catalog like terms together. So I've got these two that are the same. That's going to become a 5z squared. And then I've got these two terms that are the same. So that's going to end up being, I've got a negative 6 and a positive 7, so plus z, and then that plus 5 is kind of on its own. And my denominator is z plus 1, z minus 2. Again, I'm just going to leave this in this form. When we start thinking about graphing, having the denominator factored like that is going to be helpful for us. Subtracting denominators is the same process. We still need to make the denominators the same. We're going to subtract the fractions rather than add them. So looking at example 5a, the least common denominator, it looks like, is x plus 5 times x minus 3. So I'm going to modify each of these fractions to get them to have the same denominators. The first will be multiplied by x minus 3 over x minus 3. It's a form of 1 that will get me the denominator that I want. And the one on the right will be multiplied by x plus 5 over x plus 5. All right, I've got to distribute this 3 here. That'll be 3x minus 9. I'm going to leave my denominators in this factored form. And then moving to the next fraction, I'm going to distribute this 1. So that's a x plus 5. Okay, now here's the important part. I've got a subtraction sign in between the two fractions, and that means that both of these items need to be subtracted. So I'm going to have 3x minus 3 in my numerator. Oops, not minus x. 3x minus x in my numerator. And I'm also going to have negative 9 minus 5 in my numerator. So for my final answer, I think I'm going to have 2x minus 14 over the quantity x minus 3 times x plus 5. All right, let's do one more like that. In this example, I think that my least common denominator is going to be p plus 1 times 4p. So I'm going to multiply my fraction on the left by 4p over 4p, and the one on the right by p plus 1 over p plus 1. Multiplying this together, I'll get 16p squared over 4p times p plus 1. And then I have p plus 1 times p plus 1. Okay, that looks good. Over here, multiplying that out, we'll have p squared plus 2p plus 1. But all of those terms are going to be subtracted. So my new numerator is going to be 16p squared minus all of those items because of that subtraction sign in the middle. And then I can simplify this a little bit. Let's see, that'll be 15p squared minus 2p minus 1. And I'm going to leave my denominator in this factored form.